Hey everybody, I'm Tyler.
And hey, I'm Brian.
And today we wanted to take a few minutes and talk a little bit about best practices for fiber inspection and cleaning and just the methods and procedures that people use. Now, several years ago, standards bodies like the IEC adopted the 61335 standard, and there's been others that have followed suit. But not everybody has access to the standard or can interpret and read through this and understand what it is. And, several years ago, both of us, our companies have been really big advocates of that inspect before you connect mentality, which tries to walk things through a really intuitive workflow that anybody can understand and do. And it starts pretty simple. You inspect it. You use a microscope to look at the end face. And if it's clean, wonderful. Move forward, you can connect that, and off you go. But you've checked that, and if it's dirty, you've got to do something.
Right. Yeah, absolutely. I mean, Tyler, the whole inspect, clean, inspect, it doesn't matter what the industry is. Anywhere you have an optical interconnect, that's what you want to do. I mean, if you think about it, the number one problem that most people have with fiber optic connectors is contamination, right? Yeah. So, and when you go through and you start to put the connectors together, you want to make sure you inspect it, right?
Yeah.
I mean, how long does it take now to inspect a connector with some of the modern gear?
Yeah, it's so easy. We're talking just a matter of 2 seconds,
Right.
Just do it and you're done.
Right. And what's kind of the biggest reason you see out there that you hear about why people don't always inspect and clean your connectors?
Too many tools to carry. It takes too long, right? And so they think, I don't need to do that. I've in the past, I've gotten away with doing this for years, and I've never had a problem.
Yeah. Yeah.
But now we're in a space. I look at like the enterprise and data center space, for example. They're in a spot where they've moved beyond a gig. Now they're getting into 10 gig, 40 gig. Well, guess what? Contamination's a problem.
That's right.
Now.
Yeah.
So getting people to understand that they need to do this, start with that basic, check it. If it's clean, great, you can connect it and move forward. But if it's dirty, that's when, and going back next, you have to clean it, right?
Right.
And cleaning too. Cleaning takes no time at all now, right?
Yeah, absolutely. I mean, the number one reason we hear about why people don't always want to inspect, clean, inspect, they're worried about it for the time. But actually, if you think about it, the time that you're going to have to go back, if you have an issue that's contamination related, it's going to be a lot more time consuming and an additional expense. So if you just go through and take, a few seconds to inspect it, right? And if it's clean, leave it alone, right?
Yeah.
And if it needs to be cleaned, then go through, and there's a number of options out there now for cleaning your fiber optic connectors that are highly effective. And then once you have it clean,
then you go ahead and inspect it again.
Absolutely.
Because you don't want to just do blindly. You want to just make sure that the cleaning effort that you just did was actually effective.
Yeah.
If it's not, you do it again, give it another try. Oftentimes the reason why it doesn't come off, probably because they had previously inspected that or previously connected that, and it was dirty, so it can be a little bit more abrasive. And in future conversations and videos, we can talk about some of those, how to be more aggressive in dealing with that. But if it's clean at that point, then you inspect it again, make sure it's clean. Now you know it's clean. Now you can connect.
Yeah, absolutely. So folks, it doesn't matter whether you're doing data centers, or if you got a fiber to the antenna, you're doing something on an airplane, it's always best to always inspect, clean, and re-inspect, right?
Exactly, and then you can connect. Yeah, I mean, you've seen it all. You've traveled the globe in every application. You've talked to military guys and new equipment manufacturers. I mean, this is a principle that applies to everybody.
Exactly. You'll never go wrong taking a few seconds to inspect, clean it if it needs to be clean, and then re-inspect.
And we've been talking a lot about inspection, inspect before you connect process. And one of the biggest things that we oftentimes see people make a mistake here is they think of inspection and cleaning as a troubleshooting thing. They just ran an OTDR trace, found a problem, and they say, oh, it's a dirty connector over there. And then they go to try to address it, and they go to clean it, and the dirt is not coming off at that point. It's because they didn't do it proactively.
Right.
Now they're having trouble. And so talk a little bit, Brian, about what you've experienced as a manufacturer of cleaning solutions. How do you educate people on how to deal with it right?
Well, I mean, Tyler, the biggest thing is when you're dealing with the contamination, you almost have to think of it in two ways, right? You have residue-based contamination, you have dust-based contamination. What'll happen is with the residue-based contamination, if you go through and you made it together, essentially any kind of oils or liquids in there, it's changing the index of refraction between the two fibers, right? So if you think about it, as light's coming through, it's essentially you've changed the medium, and so you're going to have some stuff that comes out. Sometimes, typically, what you'll see from an inspection standpoint, it will be like what the coffee ring stains, right?
Yeah.
And then the other one that you'll see is also dust-based contamination. So when you start having dust-based contamination, a couple things can happen. Sometimes, depending on the placement of the dust, what you may have is a signal actually being kind of absorbed into the material. Sometimes, too, it'll cause kind of almost a back reflection. So you'll get some back scatter the signal back into the incoming fiber, which will cause problems. And then also, depending on the size of the dust particle, sometimes, too, if it's large enough and depending on what it is, you could actually have problems with it mating correctly, right? So you almost have like a slight air gap, right?
Yeah, exactly.
But Tyler, what do you see like when people go through, if they're not from an inspection standpoint with dust? I mean, what happens to the end face if you start mating it and kind of go back retroactively and try to clean it?
Well, you find it doesn't come off. You know, we find these. Somebody runs the trace. They see a problem. They go to clean it, and then it just doesn't come off. It's embedded in there, and now they've got a bigger problem on their hands. They're going to have to change that connector, get out the fusion splicer, and shut everything down for a day or so. What we're trying to get people to understand is, no matter what the type of contamination is, if you do it proactively,
yes,
none of it's a problem.
That's correct. It really comes down to doing the job the first time, right?
Yeah.
You don't want to sit there and have to try to go back and fix it, especially a lot of copper guys, right? They're kind of new to fiber. They want to open the bag, plug it in, right?
Yep.
But what happens if I plug two dirty connectors that's got like dust in there?
It's going to embed that in there, and now you're going to have problems.
And scratch the end face, right?
Yeah.
And you know, in some cases, if you're dealing with like a basic datacom connector, it's a pain. But what happens if I do it with like some of these real hardened connectors, like in fiber to the antenna or mill? It's ruined, right?
Yeah, exactly.
So you're screwed.
Now you're going to have a technician come out there in a bucket truck and go up there and take the whole neighborhood down potentially, or who knows, right? The problem being is, one of my colleagues likes to say, pay me now or pay me later. If you just deal with it on the front end, you avoid a lot of problems.
That's right.
And we've been talking a lot, obviously, about different aspects of inspection, cleaning, re-inspecting again. And we always talk about proactive inspection. Another aspect of this is making sure that when you're inspecting, a common mistake is neglecting to inspect both sides of the end connection. Everybody always forgets that probably the most common mistake that people make is, hey, did you inspect and clean? Yeah, sure. My patch cord was pristine. Everything is great. But let's not forget that there's two sides to every.
Yeah, exactly.
connection.
I mean, Tyler, if you think about it, if you go through and you only clean one end, essentially what you're going to do is actually cross-contaminate the other end face. So if I clean my patch cord, but I forget to clean the connector inside the bulkhead adapter, anything that's on one surface is going to transfer. Typically with residues, you'll actually see what I call the coffee ring stain, right?
Yeah.
And you'll see, and that's where the two ferrules come into contact. If you do it with dust, the problem is you're going to transfer the dust, and you'll have particle migration. Plus, the other thing too is what? The dust will scratch the end face, right, and cause permanent defects. But
potentially embed right in there, and now after that,
right.
if you try to clean it reactively, it might not even be removable. And so we figured I set up a microscope here just to show you exactly what this looks like. Here is actually, I've got this LC connector plugged into the patch cord microscope. Perfectly clean connector here. Now I've got in my hand, here's an LC bulkhead that I've contaminated. It's known to be dirty. Here, if you inspect that and if you look at that, you can see it's clearly dirty on the end face of that one. I'm going to take this connector, this one here that it's known to be clean, plug that in, make the connection. Now, if I hadn't have inspected this one, I had no idea that it was dirty, but I did inspect this patch cord here, and I thought, oh, it's clean, it's perfectly fine. And then I went to go plug that in, and thinking everything was good. Look at that again. Now, Brian was talking about the coffee ring effect here. You can kind of show this was a clean connector. It was plugged into a dirty port with a dirty fiber connector, and now you see what ends up happening afterwards. This is why it's important to be checking both sides.
Yeah, exactly. And then also when you're doing your testing, remember that when you're plugging in your reference cords, you want to make sure that you're keeping those clean as well. You never want to take your nice test cables, right, and plug it in, because if you do, you can actually end up causing damage to your test equipment, right?
Yeah.
As well as you could be transferring the contaminant, or actually, like you said, scratching or pitting the end face if you have dust onto your test assemblies, and that would end up skewing the results.
Yeah.
Right?
So the good news is with the cleaning devices that we have now, here's a click style cleaner. It's yours. This actually has the ability to clean both sides.
That's correct.
So maybe, I know that this is kind of a troubleshooting reactive phase right now. We've already made it, but
Yeah.
so give it a shot?
Absolutely. Let's see if we can do it in one shot.
So now normally, again, this is a practice that we'd want to do proactively before you actually made it. You run the risk, of course, of embedding that debris in there. Plug that in, and now you can see he got most of it off. And this is a great example here about why you want to inspect after every time that you clean. Let's see if we got it that time.
Yep.
Boom, there you go. And that's why you want to always inspect, clean,
And re-inspect.
So there you go. That's another aspect of inspect, clean, inspect before you connect. Never assume that just because you checked your test lead that everything is clean. You got to make sure you check.
Yeah, and you can never assume that the cables that are coming in out of the bag, or that the connectors inside the fiber management panel or equipment are always clean. Make sure you always check both ends, right?
That's right. And today we wanted to talk a little bit more about a big mistake that people make when they receive new cables and connectivity, and that's just thinking that this is a brand new cable assembly. I'm sure it's perfectly fine. I don't need to inspect it. I don't need to clean it or check it, and that ends up being a catastrophic problem for them.
Yep.
You oftentimes hear people talk about dust caps and never assume it's clean, and I can't stress enough that no matter what even the manufacturers try to do, it can leave their facility perfectly fine. But I can't stress enough that just because that worked doesn't mean that by the time the end user received it, that it's clean.
Yeah, no, I agree. I mean, Tyler, there's a number of things that can happen, right? So the factory can go through, have a wonderful process, do the testing, everything looks pristine. But sometimes what happens is when they start putting these end caps on, the protective end caps, you have things like, they'll have like plasticizers. And basically what that is, that's can cause some oil residue. And these are kind of some mold release when they actually go through and mold these, right? So you can sometimes have that get on there. Another thing that I've seen happen is you start to see dust get on there, and maybe some of that's connector wear debris that's coming on, or sometimes too, everything has gone through tested, and depending on how the end caps are being stored at the production facility, sometimes a little bit small amounts of dust, but as it gets on to the inside of the end cap and things shake and vibrate in the shipping process, it can actually get onto the ferrule end face.
You were talking about that mold example. I saw that firsthand a couple of years ago. I was working with some folks at an industry event, and there's a cabling manufacturer that was giving demonstrations of their connector, and they were showing that, hey, I could terminate this connector in the field, and I could plug it in, and everything is great. And I said, you're not checking that before you actually made it. And he said, hey, this was checked at the factory. Everything was great and wonderful. And I said, let's take a look at that just for example. This brand new connector right out of the bag, I removed the dust cap and we checked it with a microscope, and it had mold all over it, residue all over it.
Oh, wow. Yeah.
And we connector after connector, we kept on opening. He said, no, that must be a problem, just a rare occurrence. No, connector after connector, this was happening over and over. And he was paranoid started thinking about the problems of his facility. I said, no, it's not. It probably left your facility perfectly fine.
Sure.
And, who knows where it was stored. Maybe it was in a warehouse in New Orleans or whatnot. But the different environmental factors that impacted this ultimately led to, by the time the end user got it, there was this mold residue that was on the end of it. Now, the good news is all he had to do once he checked that was clean it.
Yep.
And it came right off.
Right.
So it goes back to that proactive inspection thing again. But basically, once he did that, it was a big relief. And I said, it's not your fault. This is something that's just the nature of physics, that this is going to happen. And so, but this is just an assumption. You think about copper guys. Right?
Yeah, exactly. A lot of copper guys are used to being able to take the patch cord outside of the bag and then plug it up. And if they have an issue, they'll come back and say, hey, look, we got to replace this patch cord.
Yeah, a reactive mentality.
Yes, yeah, it's a reactive mentality. But realistically, what's happening in the industry is you have a lot of guys that are pretty new to fiber. And so I think what they're doing, they have sometimes an unrealistic expectation. And it's not necessarily that once in a while, if you have a cable assembly or even a piece of equipment that has a little bit of dust on there, that the manufacturer is bad or that he's actually having quality problems. Far from it. I mean, dust and residue type contamination are things that just actually happen. But the great thing is it's a very easy problem to solve. And once you're aware of it, it's very easy to do the inspect, clean, and inspect process to make sure that you remove it, right? So the whole thing is when you open up the bag and you're pulling your jumper out or your drop cable, or even if you're sitting there plugging something into your piece of, network gear, you want to make sure that you inspect it and clean it. And again, dust happens, residues happen. It's just a fact of life, right?
Absolutely.
Yeah.
So we'd like to hear from you. If there's any, if you ever had an experience where you check a cable right from the manufacturer, again, no fault of the manufacturer, but what's the most crazy thing that you've ever seen by inspecting a connector right out of the bag?
So on this edition, what we want to do is actually talk to you about the importance of inspecting your reference cords and your test leads. One of the things that, if you think about it, these are actually a very important part of the testing process, and it's a piece of expensive gear. And if you don't take care of it, you're going to have a domino effect, right, Tyler?
Yeah, exactly. I mean, we see this all the time as a manufacturer of test equipment, that you first start off with your test equipment itself, which is very expensive, and so you want to take care of that. But then there's also, you've got your reference cord.
Yeah.
And a reference cord is not your everyday test lead. This is something that is a premium cable that you've paid a premium amount of money for because it's been polished, it's got the premium apex offset, and all the attributes are just right to make sure that there's as low loss as possible on that connection. So you paid a lot of money for these good quality reference cords, and the last thing that you want to do is treat that like garbage and not check that.
And Tyler, I'll just kind of share a quick story, but I have a colleague that actually was doing some training over in Okinawa, and he was having to do some testing, and one of the end user was basically putting pressure on him to go through and plug his reference cords into the equipment without actually inspecting it. And Tyler, what would have been to happen? Because he was actually very worried that if that happened, he's stuck, right?
You said he's on Okinawa, right?
That's right.
So he's got probably a limited supply of reference cords. And so the last thing that he wants to have happen is he's trapped on an island somewhere with a useless reference cord now.
Right.
And so if he does that, it's going to misrepresent all of his test results after that, because garbage in, garbage out. If you've got a dirty test lead and it's destroyed, you've got bad test results.
Right. And the other thing too is also if he doesn't have those right, basically those reference cables, right? He's basically got downtime. So that means basically
he's stuck on an island for a couple of weeks.
And doing nothing, right? So he's not being productive. So if you own a construction company that's actually doing the work, or if you're an end user and you're trying to get your gear turned on and they have bad reference cables, or I've crushed them. It's a bad thing, right?
Exactly. And then on the other side of that, I think of reference cables. So if you got either one of those that are bad, if you plug that into the equipment side, you can damage the actual source on your equipment. As a manufacturer of test equipment, that's the number one reason that we get returns back for our service department, is simply to address a source that was damaged by plugging in a dirty test lead to it. And then the other side, I think about you plugging that into the test equipment itself. You had the example of in Okinawa was he was concerned about the ports of that device being dirty, but I've got situations as well where we had a manufacturer who had a bad test lead, and everything that was coming off of their assembly line was actually failing when the customer received them. And so we got out a microscope, took a look at this, and it was interesting. Every single one of the ports on the device that they were manufacturing not only had contamination, they had the same pattern of contamination. So what do you think was
Ooh.
going on there?
Well, it's basically you're transferring it over, right? And so it's going to end up ruining the interface of everything that you've plugged those test leads into. So it's
Plugged one dirty test lead into this thing, and he's contaminating every single one of those ports with the same contamination.
right.
So don't be that guy.
Yeah, and again, making sure you take care of the your test leads, and it's going to help extend the life of your test gear, right? And that's very important because, I mean, if you have test gear that has to be out for servicing or that you damaged, hey, that's a big expense to you, especially if you're a smaller company and you only have so much gear. You have downtime, you've got repair time. That becomes a very expensive process, doesn't it?
Exactly. Take care of the stuff you own. And first, it may seem very simple with a test lead or whatever, but if you keep that clean, it'll keep your test equipment clean. It'll ensure that you're getting good results.
And really, what's the best way to do that? Inspect, clean, and inspect, right?
Inspect before you connect.
That's right.
And this time we wanted to talk about something that Brian is a real expert on, and that has to do with the different types of cleaning solutions that are out there. As a manufacturer of test and inspection equipment, we will always say, hey, you inspect it. If it's dirty, then clean it. We don't care what you use, but as long as it works, and then once that's clean, you verify it's clean and proceed. But when it comes to what to use, this is where something that you're really strong at. Cleaning sticks, different clickers, different other devices out there. What do you see? What do you recommend when it comes to that?
Well, I think, Tyler, a lot of times it kind of depends on what you're dealing with, right? So the trend in the industry right now is to try to focus more on, hey, I want a clicker. The advantage that a mechanical clicker has is that it allows you to clean both ends of the connector, right? So you can take the caps off, you can go through, you can clean the connectors inside the adapter and the port, and then you can put the end cap back on, you can clean your assemblies. But there's also some limitations to clickers, right? So they're a wonderful tool, but they're basically built for high fiber counts. So if you're doing something like a 288 fiber panel, something like a clicker probably makes a lot of sense. If you're dealing with lower fiber counts, for example, like if I'm just putting a 24 fiber patch panel in, maybe something like using the stick cleaner is better, right? It's going to be a little bit less expensive. And I think another thing you want to concentrate to or think about is look at the contaminants that the interfaces have been exposed to. So for example, if I'm sitting here working at an outside plant pedestal, what you want to do is probably look at the contamination that you have on, so it's important to inspect, right? And when you see how much debris is actually on the interface, sometimes a stick will allow you to be more thorough. But the clickers are a great tool that are out there. Again, just kind of thinking about the fiber counts as well as the type of contamination that you have.
Can I ask you a little bit of question about the clicker? I tend to prefer using a click style cleaner, mainly because I feel like a cleaning stick or a swab or any of those, you have to be, there kind of is maybe a little bit of a skill set there. You have to be more savvy in how to use it. And I'm terrible at it for whatever reason. And so I like to be able to go in there and if it's dirty, hey, get out my clicker. It's a controlled thing, and it works well for Tyler, and and it cleans.
Right.
Do you see that as well? Is there a craft skill set level with that, or?
Yeah, absolutely. I mean, anytime you use a stick cleaner or even a wipe, whether it be like an optical grade wipe or one of the cassettes that are out there, it's a little bit dependent upon operator technique. Now, when you go through and you use a stick cleaner, it's very simple. You put it in, you rotate it, and what I usually do is recommend rotating it several times in the same direction. If you kind of go back and forth, you sometimes, especially some of the lower grade sticks that are in the market, you can actually retransfer stuff on. Same way with the wipes. You have some people that want to try to do figure eights or go back and forth. When you wipe a connector, Tyler, the best thing you can do is just wipe it in one direction, right? So one direction with the wipe, whether it's on a cassette, or you can, with a stick, you also just want to make sure you go in that, rotate it multiple times. Don't reuse sticks, right? Because you start reusing sticks, you're actually
the guy who keeps
transfer
the one cleaning
contamination.
stick in his pocket and he keeps using that. Yeah, that's.
But there's another interesting thing too, also with sticks. A lot of times when you start getting, especially connector wear debris, it can start to build up on inside the adapter sleeve. right? And so the way the mechanical cleaners work is they have to be able to go through and rotate so that the cleaning strand goes across, right? So if you have things that are a lot of like connector wear debris, or you're worried about dust, especially in low humidity environments, if you go through and start running those clickers multiple times in consecutive shots, in some ways you can actually be tuning up that ferrule. So that contact friction is called basically triboelectric charging. And it's the same thing as like when I walk across the carpet and I touch something in the wintertime and I get that shock, it's the same thing.
So now you're potentially charging it to attract debris and dust? Is that what
That's
you're saying?
right. So anyway, the good thing is clickers have a great place, as well as sticks and wipes. And I think really it boils down to this. Think about, what is your fiber count? Am I dealing with high fiber counts or low fiber counts? From an economy standpoint, if you're dealing with lower fiber counts, maybe the sticks or the wipes are a better way to go. If you're dealing with a lot of high density patch panels, then yeah, probably a clicker. And number two, make sure you start thinking about the contamination. And the best way you can do that is you inspect the end faces, right? So you want to inspect, clean, and reinspect. But if you realize that you're dealing with things that have a heavy level of contamination, maybe going back to the traditional stick and wipes is the best way to go.
And if you just said it too, the best way to know at the end is after you clean it, inspect it again.
Absolutely.
Make sure you got that.
Because no method is 100%.
And in a previous episode, we had talked about when to use a clicker versus a stick and such. And you had talked about how in some cases with some of the clicking tools, you can build up a static charge and potentially introduce new problems. Wanted to expand on that a little bit more, because oftentimes I see these guys go out there and, click, 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 and I'm like, is that really necessary? And I go back to the IEC standard, and it says very clearly, inspect it, clean it, inspect. It doesn't say clean, 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 clean. It just says it once. Can you expand a little bit about that as a manufacturer of cleaning?
Yeah, absolutely. I mean, when you think about fiber optic connectors, probably the number one contaminant out there is dust particles, right? And this is where I think electrostatic charge is the main contributor to this. So if something starts to develop a negative charge, then all the positive charged dust particulates are going to be attracted to it, because it wants to try to get itself back to electrically neutral state. If you think about fiber optic connectors, I mean, the ferrules are either ceramic or they're composite, and the composite are actually a glass plastic.
Yeah.
So that means they're dielectric, and essentially what they're acting like is an electrical insulator when the static charge gets on. So it's not going to decay, and until you have a way of actually dissipating that charge off, Tyler, it's going to stay there for a while.
So you just got really technical there for a second, and my more simple mind gravitated towards when I was a kid walking around the carpet with my socks on. You're basically doing that, is what you're saying.
Yeah, exactly. The technical term for that is called triboelectric charging. And basically what you're doing is you kind of shuffle your feet across the carpet. What you're doing is you're disrupting the electrons on the surface. So when you have these guys that are saying, hey, you should go out there and pop your clicker 3 or 4 times to try to make sure you get it clean, in some ways you actually be doing more damage than you are actually doing something good. And again, probably the best thing you can do is when you're using these clickers is go through, inspect it, then clean it. I would say a good quality tool is going to let you get at everything within one shot, right? And that's really what the designs are. Some of them actually have names that sort of refer to the one shot.
Yeah.
But if you're having to go through it multiple times, not only are you potentially charging it, but the other thing too is you're also driving up your cost, right? And so if you're having to run this thing 3, 4, 5 times and then inspect it and do the same process, well, you might as well have gone to a stick cleaner, which could be more effective. But yeah, the static charge is I think one of the main contributors of in-face contamination, especially with dust.
And one of the things that I've seen guys who do that in the past is one of the reasons that they're doing that is because the debris isn't coming off, not because the cleaner wasn't effective. It was because they didn't do it proactively in the first place. And we've talked about this before. If they're doing that reactively, if they've already mated that connector, a lot of that debris might be embedded on there in the first place. And so it's most likely not coming off. And if it does, it's very likely could leave a chip behind anyway. So that goes back to something we've talked about before. Make sure that you're inspecting and cleaning and reinspecting proactively as opposed to reactively. And no amount of click, 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 click is going to actually solve the problem. As you were
Right.
saying, it's probably going to create more problems.
And Tyler, in some cases too, this is also where we had in a previous episode talking about making sure that when you open up the bag and you pull the cable assembly out or taking the cap off and looking at the connector in the port, can't assume that it's clean, because sometimes in the manufacturing process, and they're using clickers and they're using different cassette products that are out there, what they're doing, and it's unintentional, but sometimes what they have is a ferrule that has a static charge, or even the adapter can have a static charge. And so that's one of the reasons why you never want to ever just assume anything is clean. You always want to do the inspect, clean, and reinspect process.
And we've been talking about in some previous episodes about different cleaning methods and sticks and cleaners and such. But one thing we haven't touched on yet was using solvents versus dry cleaning. And as somebody who deals with this on a day-to-day basis, tell us a little bit about what you recommend and what you see most out there.
Sure. One of the best ways to actually get anything clean, as well as also address the static issues, is to use a wet to dry method, right? Anytime you introduce the fluid, it creates that dissipative medium to basically pull off the static charge. But one of the things that happens in the industry is they look at solvents kind of uniformly, and that's not always the right way to look at it. I mean, Tyler, what's the most common cleaning fluid that you see out there all the time?
Well, if you were to ask a doctor or my wife or somebody else, probably isopropyl alcohol.
Yeah,
right?
exactly. And if you look, a lot of installers will use isopropyl alcohol, same way with manufacturing. But one of the problems with alcohol is it's hygroscopic, meaning that basically chemically it wants to pull the water molecules in. And so one of the biggest challenges with using an isopropyl alcohol, especially when you use it in Menda bottles that are not sealed, it's constantly pulling the water in, right? And what happens if I clean something with dirty alcohol or alcohol that's been cross-contaminated? I can potentially what?
It's more, now you make it more dirty.
Yeah, and so in that case, that's, again, kind of brings back the point that you always want to go through and inspect, clean, and reinspect. You should never assume that any method is always 100% from a cleaning perspective. But one of the best things that you can do is actually start picking some of the engineered cleaning fluids that are out there. Mm-hmm. And a number of manufacturers, we have processes that we can actually recommend depending on the type of connector. But not all cleaning fluids out there are appropriate for cleaning. For example, if you're dealing with things like plastic fiber, if you're dealing with some of the more aggressive cleaning agents that are out there, they can cause deformation in the plastics, and that can be very detrimental, right?
Yeah, sure. So one thing, I mean, we hear a lot of your typical field technicians right now. They, like you were saying, they may go overboard on always doing solvent cleaning when they may not need to. But a common one right now, especially in a troubleshooting environment, of course, normally you should be inspecting proactively, and if you find contamination, if it's dirty, you clean it. Probably a dry clean is probably sufficient, mm-hmm. and then you inspect it again, and you're good to go. But let's say you're in a troubleshooting environment and you found some problems, and you need to do some kind of a wet to dry process. Can you expand a little bit more on what a good wet to dry process looks
Sure,
like?
absolutely. The best thing that you'd want to do is apply just a small amount of the cleaning fluid onto a wipe, whether it's an optical grade wipe or whether it's even like a cassette or something like that. And even if you're going to do a wet to dry with a clicker, what you always want to do is use a small amount. So you always want to try to meter how much the cleaning fluid you use. You don't ever want to use too much, for two reasons. A, it's wasteful, and then second, sometimes too, it can actually get into other parts, like back into the cable assembly, into mm-hmm. where the aramid is, and start wicking out and actually cause problems. So you always want to make sure you just use just a little bit of the cleaning fluid. Tyler, the other thing too, also, you need to think about the environment that you're in, right? So there's some people out there that have these DI water-based cleaning solvents out there, and they work well, let's say in a lab environment that's nice and controlled. But what happens if I leave something that's water-based in the truck overnight and I'm in Minnesota in January?
Yeah,
it's going to freeze, right?
The next day.
So again, what you want to do is make sure you kind of think about the environment as well as the contaminants that you have on there. But whatever you do, it's always, again, it's important to make sure that you're inspecting the interface, clean it. But then once you clean it, you always want to go back and reinspect.
Yeah, make sure it's clean. And in this episode, we wanted to talk about something that is probably prolific in any industry, but I wanted to tie it back particularly to inspection and cleaning, and that has to do with the reliability of the suppliers and the manufacturers that you work with. You know, we see it oftentimes with price pressure of test equipment and seeing other manufacturers who might not be as reputable, and so they try to sell you something as cheap as possible. And the customers oftentimes will look at that and say, hey, you can save $1 by going here. But in the end, things end up backfiring, and you end up kind of getting what you pay for. But I know that that's even more of a prolific issue when it comes to the cleaning tools.
Yeah, absolutely. I mean, Tyler, one of the things that we're starting to see as more people become aware of the inspection and cleaning process, they're looking for ways to try to save money, right? But I think they're going about it the wrong way. You're seeing a lot of companies, especially out of China, that are coming in with basically what I call like knockoff products. One of the things that you can sort of tell the difference between a legitimate product and one that's not is the legitimate products will always have the name and brand on there. They'll also usually have their contact information somewhere, so that way if you ever have an issue, they can go through and make it right.
Well, you think about oftentimes one of the decision makers in the process might be somebody in finance or accounting, and they might on the surface say, hey, I'm saving $1 or so, and so when I buy 1,000 connectors, or cleaners, I'm saving $1,000. But I know you've had some experiences before where folks were victims of that, and then they have something go wrong.
Yeah, exactly. I mean, I can think of a recent situation that was dealing with one of the maquilas down in Mexico, and they ended up buying a bunch of these, let's call it knockoff type cleaners. And when they got them, basically once they started hitting the floor, it was just a matter of about a couple hours before the operators started having a lot of problems, and it got to the point where it shut down the line. And so they ended up trying to figure out what to do. Well, the distributor that sold it basically was on the hook, right? Because he had bought him from one of these Chinese knockoff guys, and essentially he's left holding the bag. Chinese guy is not coming in with technical support, and you're sure not getting your money back, right? So it's just a very bad situation. Bad for the distributor, bad for the end user, and it's just not a good thing to do. If you're going to spend the money to do inspection and cleaning, it's important, right, to get a good quality product. So if you're buying test gear, make sure you have the software and the repeatability, the technical support, right? That's huge.
Yeah, you're not just buying the product, you're buying actually the people and the support and the knowledge base to support that.
And if you're going to take the time to sit there and inspect and clean connectors, hey, do it right. If you think about it, the cost of most projects, especially cable installation, about 80% of it is labor. Right? And so you want to make sure that when you send your folks out into the field to do that install, that they have the right tools. I kind of use the analogy. It's like taking a hammer trying to drive in a screw. It's just, I mean, it can do it, right? But it's going to end up bad, right? So,
Exactly.
So when you send your guys out and you're doing your work, make sure you outfit them with the best gear possible. And that way you don't have the truck rollbacks, you don't have the recalls. If you're a manufacturer, right, you want to have good test gear, good cleaning gear, because you want to make sure that everything's done right the first time. And on this edition, we want to talk to you about the importance of standards, specifically the IEC 613-00335. Tyler, a lot of times when we're talking to people doing the inspection and cleaning process, they start seeing the circles. Can you tell us what the circles are in the software, and what am I looking at?
Yeah, sure. Well, the 61300 standard is something that's been around for a number of years now, established by a lot of credible companies throughout the industry. We both know people and have worked with people who have sat on that standard and all the work that went into that. And basically, the logic was that they wanted to find some way to establish a level playing field for identifying how clean is clean enough. And there's all sorts of opinions and things that they tried out to what criteria to use, and where they ended up landing makes a lot of common sense, both from an evaluation standpoint and a practical implementation standpoint. Is they just put a series of concentric circles, kind of like a bullseye in an archery, or a strike zone, or if you're Canadian, a curling rink, right?
Sure.
Or whatever you guys call that up in Canada. But anyhow, it's an evaluation that the closer you are to the target in the center, which is where the core of the fiber is, where the light is transmitted, the more essential it is to keep that clean. And so whereas the zone A, or in the core, has to be very pristine and free of defects, you get out to zone B, and now there's a certain count of defects, there's a certain size, of defects that are allowable, and of course then the location of them. Then you get into zone C, which is the actual adhesive zone. We can get into that later. And then zone D, they call the contact zone. And so the farther away you get, the different criteria that you have for the amount of defects that are allowable. Now, I got to hand it to the IEC. When they first developed this, it was really primarily established for manufacturers of cable assemblies and such to have a good benchmark to evaluate their criteria when it was leaving their facilities. But it's really become adopted now. I mean, we're seeing it in TIA 568 standards, and even,
And you see a lot of the other industries actually adopting a lot of the criteria, especially the pass-fail, the amount of defects, whether it's permanent or removable defects, into other standards.
Yeah.
And then the other thing too, as see more of the MTs coming on, the IEC addresses that too, right? Different polishes.
Great point. Yeah, and I think that this has been a misnomer in the industry. You might hear some people say, well, there is no IEC standard for multiferrule connectors. That's not true. There's actually part of the standard actually does call out acceptance criteria for multiple termini ferrules as well.
That's right. Yeah. So the other thing too, Tyler, I mean, why is it important to follow the standards? I mean, one of the things we get a lot of times is, hey, why don't I just sort of look at it and figure out what I think looks good for me or my company?
Yeah, your criteria is good for you and mine is good for me, but you got to have a level playing field. So we used to see this a lot of times with manufacturers. Something would leave their facility and they would say, well, yeah, it was good enough for us, but then the contractor receives that and they, according to their criteria, oh man, that was garbage. And so then you get into this argument between the manufacturer and the contractor or the end user, and it becomes sort of a my opinion versus yours. And so this is why we love standards, right? It gives us a level playing field and a common reference that we can go back to say, this is what we're both trying to adhere to.
Or Tyler, what do you say to the guy, hey, once we plug up our LC connectors into the panel, we're done. I install stuff all the time. Why should I care about the standard?
Well, again, after that, you plug that in, but then what if you ever have to do a move out or change later on?
Or my test leads, right?
Yeah, exactly. We talked about this in previous episodes as well, is that, once you actually perform any tests, if you're not checking your test leads and making sure that those are clean, you're leaving yourself vulnerable for all sorts of other problems in your equipment and your devices under test, your ports.
Yeah. So I think it's great. I mean, the IEC 6130035 is probably the most comprehensive document out there. It addresses everything from best practices all the way to the inspection criteria. It's probably the best written document out there. Would you agree? Or?
I totally agree, and it's really easy to understand. The biggest challenge that we see in it is now how do you evaluate that? And this is where having automated objective pass-fail analysis tools actually are the most beneficial, because I'll pick on Zone B, for example. It may actually say, we're allowing to have a 5 micron particle, or a particle any smaller than 5 micron. But you and I could sit here and stare at the screen of something and say, well, I think that's 4 micron, and you can say, I think that's 6 micron, right?
Absolutely.
So I
was going to say, yeah. And so, stay tuned, because we're going to have another episode where we'll talk about the importance of having an automated software that has the right algorithms, right, to kind of go through and make sure that when you're inspecting that interface, that it actually is measuring correctly, right?
It's objective now, not just our opinions.
Right.
Yeah.
And so on this edition, what we're going to do is talk about the importance of having an automated pass-fail inspection system. There's a lot of people that make fiber scopes out there, but they're not all the same. Tyler, what is the main reason why I'd want to go through and use an automated pass-fail inspection software program?
Yeah, we've talked about this briefly on another episode, where you and I could, if the IEC inspection criteria allows for a certain size particle to be acceptable, but anything larger than that size is unacceptable, we could stare at that screen and have different opinions on what we think.
Scratches and pits as well, right? So whether it's permanent defects or removable defects.
Exactly, yeah. So having something that takes the guesswork out of that is priceless. Number one, you can now, no matter who inspects it, who checks it, and regardless of the skill level of the technician, all they do is they can go up there, use their automated pass-fail microscope, press a button, and then get an analysis result that is reliable and repeatable.
Yeah, that's one of the things I love about it. When I actually use the scopes and I'm doing some testing, it eliminates the human subjectivity. Plus, the other thing too, it also gives me the ability to have repeatability. So when I do some testing, I can go through, tell my customer, hey, here's what we did. And they can, in theory, go back, replicate the same test, and we should see the same results, right? The other thing too, I mean, isn't also having the pass-fail a great way to sort of up your game if you're a contractor that's doing installations?
Instant credibility, right? Now you're a contractor, and when you go out and do that installation and that you provide that certification report that says, hey, everything passed, and here's documentation actually showing that all of the end faces of my connectors upon approval of this project are exactly pristine. That not only ups your game, but it also is a bit of an insurance policy.
Absolutely.
So when later on, when let's say an end user comes in and starts plugging in maybe cables that they didn't inspect and clean, and then when they don't get good results, then they reactively troubleshoot that and inspect it and find a problem, and they're going to want to say, hey, you guys gave us a dirty connector. No, according to this report here, that when you signed off on this, I got a picture here that proves that this was in pristine condition when I finished the job.
Yeah. I mean, to me, again, having a good inspection scope is important, but having that software to go along with it to do that automated pass-fail, that's mission critical, right? Because, I mean, we can all take a look at it. And like you said, whether it's a scratch, pit, whether it's some contamination, it's all subjective, right? But when you have the software, it eliminates the human subjectivity of trying to determine what, pass-fail. Kind of the running joke is, hey, if you could tell the difference between a 5-micron scratch and a 6-micron scratch, you're a heck of a guy. I can't do it, right? We've both been doing it for a long time.
No, exactly. And I'd rather just go up and press a button and trust the analysis results that I get or anybody else would get the same result.
Yeah, absolutely. And the nice thing, too, is the software has these, puts it into a report, very easy to read, actually ties it back to the standard. And even if you're doing some different standards, you can go through and make adjustments, right? So if I'm doing something, I think by default by the IEC 613000335, but if I'm doing something and I need a TIA or a military or broadcast spec, I can change the software too, and it still does the measurements correctly, right?
Yeah, and we've got some contractors that really pride themselves on being better than the IEC standards. So they'll say, hey, our criteria is even more strict, and so they'll put in their own acceptance criteria, and that way they know that, hey, here's where the industry benchmark is, here's where ours is, and we've got proof on that certification report that actually shows documentation of all that. It timestamps all of it, so it really does give them a reliable credibility.
Yeah, exactly. So anyway, folks, just remember, when you have the automated software, it eliminates the subjectivity. Everything's tested to the standard. And in a lot of ways, it's a great way for you to help save the frustration of having somebody that messes with the connectors later. You can say, when I left, this is what it looked like, and it passed this standard.
It proves the quality of your work.
Outstanding. Yeah, great.
And today we are talking a little bit more about actually the value in documentation or documenting your results after you do any inspection and certification. And we've touched on this a little bit in some previous episodes, but wanted to pick on you a little bit, Brian. I know that you spent some time in your career for a while working for a cable systems manufacturer. Tell us a little bit about the value that you guys placed on documentation there.
Yeah, one of the things when I worked for this big cable system maker was we would periodically get phone calls where, hey, you've got about a bunch of jumper assemblies or some preloaded panels that are in the field. And the first reaction a lot of times with the sales guys, Tyler, was to automatically blame the factory, right?
Oh, no, what did we do wrong?
Yeah. Or what's wrong with you guys at the factory? And what saved us a lot of times is because we would have in our quality inspection process to actually go through and save some of the results. So where the value of actually documenting your work from an equipment maker or cable system maker perspective is what you're doing is you're not only going through ensuring that the quality of the product as it goes out, but you're also kind of giving yourself a little bit of protection, right? So that way, if somebody takes that dirty LC and they plug it into that transceiver or into that panel, You can
Hey,
sit
it was
there
the
and say,
manufacturer's fault. They shipped us bad stuff, right?
right. But it's also a great way to use that documentation to also help train people so they can understand best practices and better ways so that they can prevent doing that kind of damage.
Yeah. So we tie this back to the IEC 61300 standard. I mean, this is the reason why it was originally established. Going back to new equipment manufacturers and giving them a stamp that they can say that they meet, and then that's something that the customers can receive and check according to as well. It levels the playing field. But even though that was established for those equipment manufacturers, in recent years, I look at what TIA has done of adopting that IEC standard. This is making its way out into the field right now in the enterprise, in service providers. We see a lot of the service providers who are calling out that requirement now for their contractors that they hire to do this kind of stuff as well. And then, this goes back to, it gives them a clear benchmark.
Yeah, exactly. And then, if you think about it, so if you're kind of new to the industry, by going through and being able to give your customer a report showing, hey, here's when we tested the connectors, here's what they look like. And so whether it's, and a lot of them will have like a view of like a high magnification, low magnification, it really helps document the quality of the work. So it's a great way, especially if you're kind of new into fiber, to go through and help establish that confidence. And if you're one of the guys that's like a legacy guy that's been doing this, or a large company that's been doing this for a number of years, what I think you're doing is when you hand that documentation over to your customer, what you're doing is basically saying, hey, look, here's the quality of my work. And essentially that kind of hopefully feeds into the value prop.
Yeah, that's worth something for sure.
Yeah, exactly. And so what you're doing is actually showing your customer the quality of your work. And so if they're trying to decide, hey, do I choose company A or company B? And that company A is going to provide you with a test report, or they're saying, hey, we can provide that test report. And with the software now, a lot of it's pretty automated, isn't it? So it's not a whole lot of extra work for the installer, is it?
Exactly. It's so easy these days. It's a fast and easy way to make sure you're doing it right and to give yourself an upper level of credibility.
And on this edition, what we want to do is talk about the value of inspecting and cleaning today. Tyler, we're starting to see a lot more of people going into some of the higher data rates. So they're moving from the 100 meg to the 1G to 10G, and now you're starting to see some guys getting into 40G and 100G. So as you start passing more data through your connectors and through your network, why do you need to care more about inspection and cleaning?
Yeah, absolutely. I mean, we see this. Even though we've been talking about inspection and cleaning for years, you had certain folks in, let's say, an enterprise application or maybe an aerospace application who have said, hey, I've been able to get away with dirty connectors or just cleaning it on my shirt or whatever and not even checking, and everything has worked fine for me up until now. But we're reaching this point where no matter what the market segment is right now, everybody's moving beyond a gig into 10 gig, and these are the speeds in which dirty connections actually have a significant impact. And so, I mean, you look at like the TIA standard, for example, even though they call out 0.75 dB of loss in the connection, all of the design engineers are calling out more stringent requirements than that now. And if you're actually proactively inspecting and cleaning your connectors, you should be able to easily exceed those acceptance criteria. But if you're not doing that, you're totally flying blind. You're leaving yourself exposed, and the introduction of contamination onto the end face of the fiber now could make you easily miss that.
Right.
So 1 gig, 10 gig, and beyond, I'm sorry, but you can't afford not to inspect anymore.
Or think of it like this, from a sensitivity standpoint, as the transceivers and receivers are becoming more sensitive, if you have, let's say, like a scratch on the ferrule end face, right, and it's causing some kind of back reflectance back, it's causing some signal scatter to come back in, right? Yeah. So that's another reason why it's very important. Inspection and the cleaning process is going to be even more critical, right?
Yeah, I was just talking to a couple of industry colleagues this past week from multiple connectivity and test manufacturers, and this is a big deal. Back reflection is something we've had the capability to check for a long time, but now more than ever, this is becoming an important factor. And the last thing that you want to do is send that high-powered signal back and damage the source that you're sending the signal from.
Yeah, exactly. And as the components become more sensitive, the other thing too, also, if you're doing a lot of stuff, let's say in single mode, where you have to worry about your power budget. So for example, if I'm an MSO and I'm starting to add more and more subscribers further and further out, I need to be even more critical, right, of making sure that inspection clean, right?
Yeah,
Because it becomes a lot more critical. I can't afford any of that dB loss, right?
I almost have to laugh because you and I have been doing this for so long that, we start to realize that this is something that's not going away. It's like the surgeon washing their hands before performing surgery. Inspection and cleaning is clearly here to stay. The higher the bandwidths are, the more important it is than ever. And now I start thinking of things like MPO connectivity, and even the way that those ferrules are designed and such. It's almost like they're more easily contaminated than even other connectors. And so, those are the architectures that are being designed right now for 40 gig and such are relying heavily on MPO connectivity. And so more important than ever to make sure that you're keeping those interfaces clean.
Yeah, exactly. And a lot of times too, as we start getting into higher data rates, sometimes we don't always pull the cables, right? We can just go through and pull a card out in the router or the switch or whatever. And so again, it's mission critical as you start thinking about all the interconnects between point A to point B.
Yep.
It becomes a lot more sensitive.
Any connection that's out there, we love connections. We love the ability to have flexibility to do moves, adds, and changes and such. But also, that connection point is a point of vulnerability for contamination. So again, if you're dealing with fiber, you're dealing with a risk of contaminated end faces. So which is why you got to, inspect, clean, inspect.
Yeah, and even though it may cost a little bit more to get a good quality product, in the end, it's going to end up saving you a lot of money because you're not going to have the reworks and the callbacks.
Absolutely, yeah.
Yep.
And in this episode, we wanted to talk a little bit more about MPO connectivity as it's rising more and more in popularity, being used for multiple applications now in all sorts of architectures by both service providers, enterprise, and the like. We're seeing it being used more and more. There's a lot of benefits to it as bandwidth transmissions grow and grow, but there's a lot more to be mindful of as well, a lot more moving parts and such. Now, you used to work for a manufacturer of MPO connectivity. Could you tell us a little bit about some of those attributes and things that are different that we need to be mindful of?
Yeah, absolutely. I mean, the main driver for why anybody ever use an MT ferrule or MPO connector is you're able to aggregate a lot of fibers into a very small footprint. And so whether you're doing things with parallel optics that you start to see with some of the higher data rate type stuff, but even then, even in a data center just doing 10 gig, it's good to have it in there. But the MPO connector, it's a wonderful connector. However, it does have a lot of moving parts. So one of the things that makes an MPO a little bit different, in single fiber, you use the adapter to basically align the two ferrules. Yep. With an MT, it uses the guide pins and the guide pin holes in relation to the fiber holes. And that's how they line the two up. So it doesn't take much, right, to get these things off center. And that's why inspecting and cleaning is so important. But also, if you think about it, Tyler, they have a lot of moving parts. So as you plug your MPO into the adapter, there's latches on the side that keep it secure. You have a slider that's on there as well. You have guide pins going into guide pin holes. So you got a lot of stuff going on that tries to make this happen. And there's a lot of opportunity for connector wear debris. And that's why actually going through and inspecting and cleaning your MPOs is a mission critical thing.
Yeah, we got a lot of contractors right now who are starting to migrate into MPOs, and they're just actually wanting to pull their hair out because they're finding it's a lot more painful to keep these things clean. Some of them just say, hey, I hate working with these things because it's just a lot of more work. Number one, there's more fibers in there to check.
Yes.
But second, even the end face of the ferrule, whereas a typical simplex fiber has the radius to it, that's got a flat end face. So no matter where the defect is, if there's dirt on there, it's going to get mashed together and it's going to explode and go everywhere. And so this goes back to now to even we've said before, some people might say that there's not an IEC standard for MPO connectivity. There is. It's always been there. And so making sure that you can inspect and clean and reinspect and test according to the IEC standard for MPO is, again, critical, as we've talked about in the past.
Yeah, exactly. I mean, if you look at it, like you were saying, Tyler, it is a flat surface. So the flatter, the better, right? And you do have a little bit of fiber protrusion where the fibers sort of stand out, but you're basically just talking a few microns. Yeah. So knowing that it's so tight in there, you got to make sure that you don't have any scratches going across the array because that can cause problems, especially if you're doing anything that's using the multiple channels in there. The other thing, too, is also you lose some of the robustness that you have, like you said, with the radius of curvature that you see on the single fiber connectors. I mean, hey, it's a great connector. It's a little bit different, kind of like cars and pickup trucks, right? One's not better than the other. It just depends on what you're trying to do. And so in the case of the MPOs, you just have to treat a little bit different than what you do with your single fiber. But still, using the inspection and cleaning process and looking at it for in-face defects is important.
Yeah, absolutely. You know, I had one person tell me they view MPO connectivity as a bigger dirt trap, and there's a lot of different reasons behind that. But at the end of the day, you still have to inspect, you still have to clean and reinspect. And the biggest barrier that we've had in the past is people don't like to do it because it's perceived as taking longer.
Yeah, it takes a lot longer time. But that's changing, though, isn't it?
Absolutely, yeah. We got new products now,
like your Sidewinder, which is an automated inspection process.
Yeah, so that that takes it down to what used to take a couple of minutes, and now it's just a matter of a few seconds, and you can check all 12 or 24 fibers or whatever. And again, makes it a lot easier to do the right thing and do that proactive inspection, cleaning, inspection.
And if you think about it too, the MTP or MPO connectors are a lot more expensive than your standard LC or SC connectors. So again, from a cost standpoint, making sure that you have something that can go through and accurately inspect those fibers very quickly to the standard, as well as document those results, right?
That's right.
That's key, isn't it?
Yeah, and you see where MPOs are being used right now for a installer and a contractor. Those are the folks who really want to up their game with credibility. So documentation is key for those customers.
Yeah, absolutely.
So using MPOs, love to hear your stories about how you've been using MPOs in your applications. I mean, they're here to stay, and we're seeing them all over the place. Love to hear your stories about the work you've been doing with them. Until next time, I'm Tyler.
I'm Brian. Thanks for watching.